Class 3 Ohm's law. So Ohm's law states that current flowing through a conductor between 2 points, okay, is directly proportional to the voltage existing across these 2 points, provided temperature remains constant. Okay, second statement is easy. So mathematically we say current is proportional to V at constant temperature. This constant of proportionality is called as resistance. So we will write I is equal to V by R, or V is equal to IR, or like this. If you have more batteries in series, you will get higher voltage. See, both are connected in series, plus to minus, and then first battery's minus plus is taken, second battery's minus is taken to the bulb, and internally plus of one battery is connected to minus of another battery. You will get same battery voltage. Total resistance will now become is 6 ohms. So you will get 0.5 ampere current. Here you have 3 volts, 1.5 into 2, here 1.5 into 4, so you will get 6 volts here. The resistance in the circuit is 6 ohms, means bulb's resistance is 6 ohms, so you will get here 1 ampere. 6 batteries means 6 into 1.5, 9 volt. Bulb resistance is 6 ohms, so you will get 1.5 ampere. Now if the bulb's resistance is say 12 ohms, you will get for this condition 3 volt so much amperes, 3 by 12, 6 by 12, 9 by 12. So the point is, if you increase the voltage, current will increase. If you increase the resistance, current will decrease, because current is proportional to voltage and inversely proportional to resistance. One analogy is given here. Voltage means height of the water, ampere means discharge, resistance means area. If there is more area, more current will flow. If the area is lesser, resistance is more. This is not exact comparison, but an idea. Voltage means head of the water, or the potential at which it forces the electron flow. Here in water head, it is the height of the water that forces or is responsible for the discharge. And then discharge is also determined by the resistance. So Ohm's law experiment, you have done this in the class. So you have a battery here B, then you have a variable rheostat to vary the current. and a fixed resistance R, rheostat RH, and then a switch or plug key K. A voltmeter and an ammeter are placed across and in series in the circuit. Ammeter is always placed in series, voltmeter is always connected in parallel, because ammeter has to measure current, so it has to be in series in the path. You can connect ammeter here, 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 anywhere in the circuit. Voltmeter you have to connect across R only, means where you have interest to measure voltage. Now, first you keep the rheostat at highest value, means here, then switch on the circuit. Some current will flow in the circuit according to value of rheostat and this R and battery voltage. Note down the readings V and I. Then vary the rheostat in steps gradually, say from here to here, here, here. So current will go on increasing. At each step you note down both the meter readings. So by taking 4-5 readings, it is enough. Then you calculate V by I. You will get resistance. All the 4 readings should give approximately same values. Means V by I values should be same. Applications of Ohm's law. It is simple and it can be used in many circuits for simplification and calculation purpose. Limitation means it cannot be used in electrolytes, diodes and non-linear resistances. See, diode is a unilateral circuit. There Ohm's law cannot be used. In electrolytes also it cannot be used. It cannot be used for non-linear resistances, capacitances, etc. So it is usually used only in metallic conductors, and that too only constant temperature. If temperature is varying, the results will be erroneous. Now, electric energy. Electric energy is the energy derived from the electric potential energy or kinetic energy. So it is the unit is given by E or usually W, sorry, the symbol, and unit is joule. Higher unit is kilowatt hour, and a very low unit is there, electron volt. So energy is given by Q into V, where Q is the charges and V is the voltage. So electric charges move by batteries or static electricity or lightning. Power is given by V into I. So energy is equal to V into I into T. Energy is equal to power into time. Vi into T is equal to V into IT is equal to VQ. Hence we write as QV. Okay, all these things are you know. So by Ohm's law, application of Ohm's law, you can simplify or get many equations. There are some questions which you have. If you have any doubt, you can ask. problems are there. In case you have any doubt, you can ask. It is very simple. Resistance in series. When you connect resistances in series, the resultant resistance will be sum of all the resistances. When you connect resistances in parallel, 1 by resultant will be equal to 1 by sum of 1 by individual resistances.